Assalamualaikum and hi, my name is Nur Afika Atira binti Nazir. My metric number A19A0490. Today I would like to talk about introduction of statistic number of educational institution from year 2019 until 2018. Statistic may be a variety of mathematical analysis that use quantified models, representation, and synopsis for a group of experimental or work study. Our group target is to find information on the statistic of the number of educational institutions in Malaysia for 2018, 2017, and 2018. The data is secondary data we got from article Department of Statistik Malaysia to measure the number of educational institutions in Malaysia for year 2016, 2017, and 2018. For this study, our group used secondary data and quantitative variable.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Yasmin Izzati binti Muhammad Yusuf and my matrix number is A19A0991. So in this presentation, I'm going to present about graphical representation data. So basically, variable data is divided into two, which are quantitative data and also qualitative variable data. But in this assignment, I'm going to focus on quantitative data. Based on quantitative data, we can build another three graphs, which are histogram, frequency polygon, and also ogive. By this collected data, we found out the data is quantitative, so means we can build histogram and ogive. Histogram. The horizontal scale is quantitative and measures the data values, either class midpoint or class boundaries. The vertical scale measures the frequencies of the class. Next, to construct an ogive, include cumulative frequency as one of the columns, specify the horizontal and vertical scale, plot points that represent the upper class boundaries and their corresponding cumulative frequencies, and then connect all the points. So that's all from me. Thank you.
My name Nur Afika Atira binti Nazir. My metric number A19A0490. Next, I want to talk about numerical descriptive measure of educational institution in Malaysia for year 2016, 2017, and 2018. This is the table of class interval that we use to calculate mean, median, mode, range, sample variance, standard deviation, and quartile. The total of frequency is 24. Total of midpoint is 1940470. The total of fx is 42174. Total of cumulative frequency is 105. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Salma Husna binti Mama Hizan and my matrix number is A19A0820. So today I will present to you number 4, which is statistical analysis using software. So 4.1 is numerical descriptive measures. for your information, I'm using SPSS. So this is the result from the SPSS for statistic number of education institutions in Malaysia for the year 2016, 2017 and 2018. So as we can see here, we have a median, mean, mode, standard deviation, variance, range and percentiles. As we know, the numerical descriptive measures have three measures. So for the first measures is measures of central tendencies. From the table, we can see that the mean and the mode in manual and SPSS result show a different result, which is the manual and the result of SPSS is not same because SPSS does not read the data accurately. Second is measures of position. In measures of positions, we have quarter 1, quarter 3 and range. So for the quarter 1 and quarter 3, in manually and in SPSS show a different result, while the range is show the same result in manual and in the SPSS. Third is measures of variation. In measures of variation, we have simple variance and standard deviation. Simple variance and standard deviation in manual result are bigger than the SPSS result. So the result is not same because of at SPSS the data cannot read accurately. Next, we will move on to 4.2, which is hypothesis testing. For hypothesis testing, I'm using two tests, which is first is paired sample test and second is ANOVA test. For paired sample test, I'm in SPSS. I'm run with a two pair. Pair 1 is quantity and year, and pair 2 is quantity and institution. So as we can see, the means for these two table from the means for paired sample test for pair 1 and pair 2 show the different result with means in ANOVA. So the population being studied are normally distributed. And in the year 2016, 2017 and 2018, a sample of 8 education institutions in Malaysia showed a mean 1,294.33 with standard deviation of 2,614.883 for pair 1 of quantity or number of the education institution and year. For this paired sample test, it has no outliers with a large data set. For the ANOVA table, the p-value is less than 0.0005, which is less than 0.05. So the regression model fits the data.
Hi, Assalamualaikum. My name is Siti Alna binti Hassan. My metric number A19A084X. Okay, today I will talk about the correlative analysis. This is table correlative analysis from the SPSS. Okay, the correlation table is between the years, institution. We have 3 institutions is primary school, secondary school and higher education, and also quantity based on the data. The Pearson correlation of the between years and years, institution and institution as well as quantity and quantity is 1. That means a value of R is 1 implies there is a perfect correlation. However, the correlation shown based on the table above is significance of the 0.01 level is too tight. Next, confidence interval. We using the 95% confidence interval that is 0.5 significance levels to do the confidence interval. The 95% confidence interval low bound for unstandardized residual is negative 3521915. And then the 95% confidence interval upper bound for unstandardized residual is 3521915. Lastly, the confidence limit range is 2.002 275. Okay, that's all from me. Thank you.
Hello and Assalamualaikum. My name is Kasdina binti Muhammad Hisham and my mention number is A19A0799. Okay, so for this presentation, I will present for number 5, which is about theoretical modeling. So for theoretical modeling, we have to come up with regression analysis. As we can see from the table, the model example is y equal to b0 plus b1x1 plus b2x2, which means that y is number of institution. b0 equal to 4785.226. b1 equal to 2.250 and x1 equal to year. And then for b2 is equal to negative 776.310 and x2 equal to level of education. Okay, so from that we can come up with the equation, which is number of institution equal to 4785.226 plus 2.250 for the year, minus 776.310 for the level of institutions. After that, every unit increase in year, number of institution will increase by 2.250, provided the level of institution remain unchanged. Similarly, for every unit increase in level of institution, the number of institution will drop by negative 776.310 units, provided that the year is still same. Okay, so that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nur Shazwan binti Abdullah. My metric number is A19A0634. So today I will continue about the theoretical modeling. Okay, the test of normality. Okay, this is data of the test of normality. Okay, the left is Kolmogorov-Smirnov and the right is Shapiro-Wilk. Okay, so I will analysis about the data test of normality. Okay, the Kolmogorov-Smirnov test of normality on the number of institutions give a p-value 0.000, which is less than 0.05 alpha. Thus, the assumption of not-normality of the number of institution term is made. Okay, why is not normality? Because the p-value less than alpha 0.05. Okay. So, and then the Shapiro-Wilk test of normality on the institution give a p-value of 0.000, which is less than 0.05. Thus, the assumption of not normality of the institution term is made. So, the same with the Kolmogorov-Smirnov with not normality. Next is a model or summary. So, look at the data of the model summary. Okay, the predictor constant is a level of education institution and year. And then the dependent variable is a number of institution. Okay, so I will analysis about the model summary. So the R-square value is 0.483. So look at the data of model summary. R-square 0.483. Okay, which means 48.3% of the variation in number of institutions can be explained by level of education institution and year. Okay, to adjust R square, so look at the data of the model summary. Adjust R square 0.434%. The Darby-Watson statistic is 0.337, almost 1. So the data at the model summary is Darby-Watson at 0.337. So that's all from me. Thank you.
So, to be concluded, we have learned well in this subject by practicing all the methods taught by the lecture before. The most highlighted part is using the new software, which is SPSS. It's quite tough at first, but after we keep on practicing and asking others, and we did it. Based on this experience, we learned other skills. We learned about all this thing is one of the qualifications we needed to get a job. Last but not least, ANOVA. Basically, ANOVA is statistical method in which the variation in a set of observation is divided into discrete components. So that's all from me. Thank you.